Hello friends, in this video we will discuss about attacking reagents. This is the way by which an organic reaction is taking place. There is an organic molecule which acts as substrate. There is attacking reagent which attacks on the substrate and form intermediate, and this intermediate will give products and byproducts. Clear? Reagent attack the reactive site of the substrate. Okay, now what is this reactive site of the substrate? The reactive site may be electron deficient portion of the molecule, that is a positive reactive site. For example, an atom with incomplete electron shell or the positive end of the dipole in the molecule. If the attacking species is electron rich, it attacks these sites. Okay. If attacking species is electron deficient, the reactive site for it is that part of the substrate molecule which can supply electrons. For example, electrons in a double bond. In this way, an organic reaction is taking place. Now, what is this attacking reagent? The species that attacks a substrate molecule or intermediate and forms a product is called attacking reagent. It is of two types: electrophilic reagent or electrophiles, nucleophilic reagent or nucleophiles. We will discuss one by one. First come to electrophiles. A reagent that takes away an electron pair from a reactive site. Takes away an electron pair from a reactive site is called electrophile, and this is represented as like this. That is electron seeking, and the reaction is called electrophilic. Electrophile means electron loving or negative charge loving. An electrophile is a species that accepts a pair of electron, because this is electron deficient, okay, to form a new covalent bond. And electron deficient species are known as Lewis acids. So electrophile is a Lewis acid. For example, carbocations, electron deficient species like AlCl3, and neutral molecules having functional groups like carbonyl group CO, or alkyl halides, that is R3CX. This is carbocation. This carbon is positively charged. Okay. So it takes away an electron pair from the reactive site. So this center is electrophilic center. Now in BF3 and AlCl3, boron and aluminium both are electron deficient. Their octet is not completed. So again, these are electron deficient species. So they love to electron. Now, in this carbonyl group, as we know, oxygen is more electronegative. So, this oxygen acquired the negative charge and this carbon acquired the positive charge. So, this carbon is the electrophilic center. Now, in case of alkyl halide, again, halogen is more electronegative. So, this acquired the partial negative charge and this carbon bears the partial positive charge. So, this carbon is a electrophilic center. Okay. Nucleophiles. A reagent that brings an electron pair to the reactive site is called a nucleophile, and this is represented like this Nu, and this electron pair is represented. That is electron seeking, and the reaction is then called nucleophilic. Nucleophile means nucleus loving or positive charge loving. A nucleophile is a reactant that provides a pair of electrons to form a new covalent bond. You can see this donate the electron pair. So this is Lewis base. For example, negatively charged ions with the lone pair of electrons such as hydroxide, that is OH minus ion, cyanide, Cn minus ion, anions, neutral molecules such as H2O, R3N, R2NH, etc. because they have this lone pair of electron which can be donated. Can also act as nucleophiles due to the presence of lone pair of electrons. Okay, so we can say electrophile means electron loving. Nucleophile means nucleus loving. Clear? During a polar organic reaction, a nucleophile attacks an electrophilic center of the substrate, which is that specific atom or part of the substrate which is electron deficient. Similarly, electrophiles attack at nucleophilic center, which is the electron-rich center of the substrate. Thus, the electrophiles receive electron pair from the substrate when the two undergo bonding interaction. A curved arrow notation is used to show the moment of an electron pair from the nucleophile to the electrophile. Now, electron moment in organic reactions. The moment of electrons in organic reactions can be shown by curved arrow notation. To show the change in position of a pair of electrons, curved arrow starts from the point from where an electron pair is shifted, and it ends at a location to which the pair of electron may move. See, now this Y is any atom. One side double bond is there and other side single bond is there. Double bond means sigma bond and pi bond. So electron will move from pi bond to adjacent bond position. So this is represented by this curved arrow. Okay, it means electron pi electron यहाँ से shift होकर के यहाँ पर move कर रहे हैं. Okay, after the moment of electron we will get this one. So these electrons are moved from pi bond to adjacent bond position. Now see in this way, इस केस में यहाँ से pi electron इस atom पर जा रहा है. Okay, then we will get this one. So electrons are shifted from pi bond to adjacent atom. Now in this one, यहाँ से electron इस atom से adjacent bond position पे जा रहा है और जब यहाँ से electron यहाँ shift होगा तो यहाँ पर pi bond बनेगा and we will get this one. So electrons are shifted from atom to adjacent bond position. Is that clear? Moment of single electron is indicated by a single barbed, that is fish hooks, that is half-headed curved arrow. See this one. Now in this complete electron pair is shifted to this carbon. So we use this curved arrow notation. But from this bonded pair, okay, from this bonded pair, this electron is shifted to this position. Okay, so again we use this curved arrow notation. We will get this Br minus. Now in this, the electron from this bonded pair of electron, one electron is shifted to this carbon and one electron is shifted to this chlorine. That is single electron is shifted. Okay, and shifting or moment of single electron is indicated or represented by the half-headed curved arrow. This one. This is half-headed curved arrow. Okay. Now see some questions. Problem 12.11. Using curved arrow notation, show the formation of reactive intermediates when the following covalent bonds undergo heterolytic cleavage. Okay. First one is this CS3 SCS3. Now in this case you must know which one is more electronegative. Okay, so sulfur is more electronegative. So the bond electron from this bond will shift to this sulfur. Okay, so this is a curved arrow and we will get these species. Now in case of second CH3CN, CH3CN. Now in this case this heterolytic cleavage is taking place. So the bonded pair of electron from this bond will shift to this carbon and we will get these species. Now in this CH3Cu, now this is a metal, this is electropositive, okay, and carbon is electronegative. So bonded pair of electron of this bond will shift to this carbon. So this is a curved arrow. We will get these species. Now problem 12.12. Giving justification, categorize the following molecules and ions as nucleophile or electrophile. These are the species given to you. after the discussion, it is clear to you what is nucleophile and what is electrophile. Nucleophile means nucleus loving. Okay, nucleus loving means जिसके पास में इलेक्ट्रॉन ज्यादा है. तो इलेक्ट्रॉन ज्यादा कैसे होंगे? या तो लोन पेयर के रूप में होंगे या नेगेटिव चार्ज के रूप में होंगे. ओके, वो होगा आपके पास न्यूक्लियोफाइल. और इलेक्ट्रोफाइल क्या होगा? इलेक्ट्रोफाइल मींस इलेक्ट्रॉन लविंग. ओके, नाउ हु विल लव इलेक्ट्रॉन? इलेक्ट्रॉन इज नेगेटिवली चार्ज, तो डेफिनेटली जिसके पास में इलेक्ट्रॉन कम है, जिसके पास में इलेक्ट्रॉन कम है. इलेक्ट्रॉन किसके पास कम रहेंगे? या तो इलेक्ट्रॉन डेफिशिएंट स्पीसीज है, इलेक्ट्रॉन डेफिशिएंट स्पीसीज है, या उसके ऊपर पॉजिटिव चार्ज है. ठीक है, तो आप इसमें से आइडेंटिफाई कर सकते हैं. नाउ सी दिस इज HS1, नेगेटिव चार्ज आ रहा है, न्यूक्लियोफाइल. BF3 यहां पर बोरॉन एक इलेक्ट्रॉन डेफिशिएंट है, सो दिस इज इलेक्ट्रोफाइल. नाउ यहां पर नेगेटिव चार्ज आ रहा है, दिस इज न्यूक्लियोफाइल. नाउ यहां पर एक लोन पेयर ऑफ इलेक्ट्रॉन आ रहा है, दिस इज अगेन न्यूक्लियोफाइल. ओके, दिस इज Cl प्लस, पॉजिटिव चार्ज आ रहा है. ओके, सो दिस इज इलेक्ट्रोफाइल. नाउ दिस इज CH3C, ये इस पे पॉजिटिव सेंटर आ रहा है. ओके, सो दिस स्पीसीज, दिस इज इलेक्ट्रोफाइल. नाउ दिस इज H2N नेगेटिव, नेगेटिव चार्ज आ रहा है, सो दिस इज न्यूक्लियोफाइल. NO2 पॉजिटिव चार्ज आ रहा है, दैट्स व्हाई दिस इज इलेक्ट्रोफाइल्स. देखिए, तो सिंपली वी कैन से these species, it means these have unshared pair of electron which can be donated and shared with an electrophile. Now, in this, reactive sites have only 6 valence electrons, can accept electron pair from a nucleophile. So you have to justify these as a nucleophiles and electrophiles. Now, problem 12.13. Identify electrophilic center in the following. Okay, this is CH3CH double bond O. Now in this case, this oxygen is more electronegative, so these electron pairs are more close to oxygen, so this oxygen will acquire the partial negative charge and this carbon will acquire the partial positive charge. Okay, now electrophilic center means electron loving. इलेक्ट्रॉन लविंग, जिसके पास में पॉजिटिव चार्ज होगा वो इलेक्ट्रॉन को लव करेगा. तो ये आपके पास दिस स्टार से इंडिकेट करिए दिस इलेक्ट्रोफिलिक सेंटर. नाउ इन दिस केस दिस इज CH3CN. okay, now in this case this nitrogen is more electronegative, so this is electrophilic center. Now in CH3I, okay, I is more electronegative, so this carbon bears the positive charge, partial positive charge, so this is electrophilic center. Okay, so the starred carbon atoms are electrophilic centers as they will have partial positive charge due to polarity of the bond. Okay, thank you. Subscribe my channel to get the next video from this chapter.